Alright, so today we are going to be going through 4.1, solving inequalities using addition and subtraction. We're first going to start out with some vocabulary. Our first vocabulary word is a graph of a linear inequality in one variable. The first thing we want to point out is inequality. An inequality is something that's not equal. So we've been talking about equalities, now we're going to be talking about inequalities. So the graph of a linear inequality in one variable is the set of points on a number line that represents all solutions of the inequality. And we'll do some examples so that this makes more sense. Our other vocabulary word is equivalent inequalities. Remember, equivalent is another word for equal. So it's inequalities that have the same solutions. Alright, a key concept that we are going to use is the addition property of inequality. We've used the addition property of equality when we were solving equations, and this is the exact same thing. The only difference is we have inequalities. To remind you of what an inequality is we either have a greater than sign, a less than sign, a greater than or equal to sign, or a less than or equal to sign. So what the addition property of inequality says is if you add something to one side of the inequality, you must add it to the other side. We know this from equalities, so it's nothing different. Alright, so our first example, we want to write an inequality represented by the graph. Now, here what we're going to use is we're going to either use greater than, less than, greater than or equal to, less than or equal to. Now, when we're graphing inequalities, we need to know that we have to draw a circle at the number. So if we have a greater than or less than, we have an open circle. If we have greater than or equal to, we have a closed circle. So if you see a line underneath our inequality sign, fill in the circle. Our first example, we have negative 6.5, and we have an open circle. That means we're either going to use greater than or less than. And how we're going to set this up is, first of all, your variable, which we're going to be using x here, is always on the left-hand side, and our number, where our line ends, is going to be on the right-hand side. Now, what we have, we need to choose which one of these is the correct answer. To check it, how we look at it is we have our arrow going up. When we draw our arrow, is our line pointing up or is it pointing down? Here, it's pointing up. So our answer is x is greater than negative 6.5. Now our second problem, we want to write an inequality. The first thing we notice is we have a closed circle at 4. So we're either going to be using greater than or equal to or less than or equal to. We need to figure out which one it is. First of all, we have our variable on the left-hand side, and we have the number where our dot is on the right-hand side. Now we want to pick numbers that are less than 4, because we have 3, 2, 1. So our answer is going to be x is less than or equal to 4. We can check. We draw a line. Our arrow is pointing down, which in our problem, the arrow is pointing down. So we know that that is the correct answer. All right, so now some other problems. Our first example that we are going to go over is x minus 5 is greater than negative 3.5. Now this problem looks familiar from what we were doing in chapter 3. The only difference is we don't have an equal sign here. We have a greater than sign. So when we are solving these problems, our goal is the same thing from last chapter. It's to get the variable by itself. So we want to get x by itself. In order to do that, we need to get rid of this negative 5. We're going to use the inverse operation, just like we did in last chapter, So we're going to add 5 to both sides. On our left-hand side, we're going to be left with x. We copy our sign, which is greater than, and negative 3.5 plus 5 is going to give us a positive 1.5. And that's our answer. Alright, so we can check our solution. Checking it is a little different than we did in the last chapter. Our answer here is x is greater than 1.5. That's telling us that our x needs to be any number bigger than 1.5. You can choose 1.6, you could choose 1.7. I'm going to choose an easy number, so I'm going to choose 2. So we're going to check our answer. I'm going to substitute 2 in for x. So we have 2 minus 5. We need to make sure that that is greater than negative 3.5. So when we do that, we have 2 minus 5, which is negative 3, greater than negative 3.5. Now, this is a true solution. You have to remember when we have negatives, the bigger the negative number, the smaller it is. So negative 3 is greater than negative 3.5, so our solution is correct. Our next example, we are going to do x minus 9 less than or equal to 3. Now, we're going to solve this the exact same way. We need to get x by itself. In order to do that, we can add 9 to both sides. We're left with, on the left-hand side, x. Bring down our sign, which is less than or equal to 9 plus 3, which is 12. So our solution is x is less than or equal to 12. We can check the solution the same way we did with the last one. Since our answer is less than or equal to 12, we need to pick any number that's less than 12. You can choose 11.9, 11.8. I'm going to choose an easy one. I'll pick 11. So we substitute in 11 for x, and we copy down the rest of the problem. So 11 minus 9. We make sure that that is less than or equal to 3. When we do that, 11 minus 9 gives us 2. Is 2 less than 3? Yes, it is. So our answer is correct. All right, we can also graph this equation, or this inequality. In order to do that, we draw a number line. And you want to first pick our point. So we have 12 as our answer. So that's where we're going to start. So we'll say that this is 12. And just number some points. So we have 11, 10, 9, 8. And now we need to graph it. Our solution is all the numbers that are less than 12. So we have 11.9, we have 11.8, we have 11, 10. So what you're going to do is you're just going to draw a line that includes all of those points. And how we do that is we can't draw a line forever, so we're just going to put an arrow, which tells us that our solution is any of these numbers below 12. It's a closed circle because there's a line underneath. That means that it includes 12. So anything below that is a solution. And our last example that we're going to do is p minus 9.2 is less than negative 5. So our goal here is to get p by itself. In order to do that, we need to add 9.2 to both sides. What we get on the left-hand side is p. Now don't get scared if we have decimals. Remember how we set them up? We have a 9.2 is positive. We have a negative 5, so 9.2 is a bigger number, so our answer is going to be positive. And you subtract the two numbers. So we have 9.2. We're going to take 5 away from it. When we do that, we get 4.2. So p is less than 4.2. And this is our solution. We can check our solution because we always check our solution. Our answer is less than 4.2, so we can pick any number that is less than 4.2. You could pick 4.1. I'm going to pick an easy number. I'll just pick 4. So you take 4, you substitute it in for p. So 4 minus 9.2, we need to make sure that that is less than 5, negative 5. So we have 4 minus 9.2. We have 4 is a positive number, negative 9.2 is a negative number. We keep the negative and we subtract the two numbers. We get 5.2. So negative 5.2, is that less than negative 5? Remember, since we have negative numbers, the bigger the negative number, the smaller it is. So yes, it is true. And we can also graph this. Our point is going to be at 4.2. We have a less than, so it's an open circle. And we're going less than, so it's every number that is smaller than 4.2. So we're going to take our line and we're going to draw it going down the number line. So this would be 3, this would be 2, this would be 1. And to make sure that we know that it's every number less tin 4.2, we draw in our arrow. And that is our solution.